Okay guys, here is a short video explaining alkene stability. Understanding how stable an alkene is a fairly simple yet important topic in organic chemistry. So anytime we use the elimination mechanism, it will always result in the formation of an alkene. And when we start talking about the addition mechanism, those always start with an alkene, and it will be important to know what side of the alkene is more substituted. The more substituted an alkene is with R groups or carbon-to-carbon bonds, the more stable it is. Now, when I say carbon-to-carbon bonds, the first time I say carbon is the one directly involved in the double bond. The second time I say carbon, I'm talking about this one right here. One question I like to ask students on this particular molecule is which side is more substituted? That's my most common answer because there's 100 carbons, and it's wrong. It's not the side with the 100 carbon chain. It's this side because it has two R groups, whereas the other side just has one. So our least stable alkene would be this primary alkene. We call it primary because there's only one carbon-to-carbon bond. And our most stable would be this quaternary because it has four carbon-to-carbon bonds. So just to make sure you guys understand this concept of more substituted, less substituted, R groups, carbon-to-carbon bonds, that kind of thing, let's look at this tri-substituted alkene right here. I'm going to highlight each R group so you can see it. This would be the first one in yellow. This would be the second one in blue. And this would be the third one in green. So I have three carbon-to-carbon bonds, or R groups. When we compare these two di-substituted alkenes, the trans will be more stable than the cis. This is due to a very important theme called steric hindrance. Remember that these methyl groups here and here are sp3 hybridization, so they occupy three-dimensional space. In the cis conformation, these two methyl groups here are all up in each other's business. They're much happier in the trans conformation when they're further apart and less hindered sterically. If you found this video helpful, but you need a little more practice or in-depth explanation, you can find the full-length version over at orgogoat.com. Please like, comment, subscribe to help our videos find more students like you, and tell a friend. If you're interested in private tutoring, or if you want a concept explained that you don't see on our YouTube page, shoot me an email at orgogoat@yahoo.com.